Hello, this is a demonstration of our oxygen analyzer. So as you can see here, we have the microcontroller housing and the LCD screen right here. Here you see the two wires for the power adapters. There will be two power adapters which need to be used to power the system. And we have RS485 cable here, and I have connected RS485 to USB converter just so that I can do a demonstration of the Modbus protocol communication, Modbus RTU. This is the body of the oxygen analyzer. So you see the big flange over here, which will be used for mounting it onto the duct. And here you have one thermocouple inside, which will measure the temperature of the flue gas. And inside here you have the oxygen analyzer sensor. Just some precautions on using the oxygen analyzer. So here is the mesh which filters out particulate matter from entering the oxygen sensor. So if it gets blocked, there will be a message, there will be a warning which will be given out by the oxygen analyzer to clean the filter. And this can be opened from here and cleaned, and then you put it back. But when you put it back, just you need to make sure that this is not wet. It is completely dry, so that we don't want water vapor or water droplets to be coming in contact with the oxygen sensor, because oxygen sensor does not like thermal shock. It can crack and it can get damaged. So that's one precaution. And the other precaution is that these two bolts, one of these bolts has the thermocouple and the other one is for a test thermocouple for calibration. So it is essentially empty. But please do not rotate this because that can mess up the thermocouple inside. So for uninstalling the thermocouple or the oxygen sensor, first they have to be disconnected from inside this, and only then it can be dismantled. So these are the precautions that one needs to keep in mind. And the second is that the oxygen sensor should not be turned off and on too often, because again it does not like thermal stress. And if you are putting the oxygen analyzer onto a flue duct and the flue duct is not yet hot, as in hot exhaust is not yet flowing through it, then it's better to keep it off. Once hot exhaust starts flowing through this and the temperature here equalizes to the temperature of the exhaust, only then you should switch it on. This will enable the oxygen sensor to last longer by avoiding. So the first thing that you need to do is you need to remove the SD card while setting up the system. So the SD card is available here. So I've opened the top, and this is how you remove the SD card. And this SD card will be read using an SD card reader, and there we will see 3 different files where different settings can be changed as required. Okay, so here we open the SD card that we just removed from the oxygen analyzer. So as you can see, there are 4 different files in this. So the TC calib, you don't need to do anything. This is something which is recorded when the thermocouple is calibrated. But the 2 files, main files of interest, would be the Modbus and the oxygen calibration file. The LoRa also, you don't need to make any changes to it. So the oxygen calibration file, open it. You can open it in WordPad. It's in CSV format. As you can see, there are only 2 data in this. One is the fuel number, and the other one is the atmospheric ADC. This ADC is something which is recorded by the oxygen analyzer and stored here when the oxygen calibration is done. So this value is recorded automatically by the oxygen analyzer and does not need to be changed by the user. But the fuel number, in the provided manual, the fuel numbers are all given from 0 to 20. So you select the fuel which is going to be used in the furnace in which this is going to be installed. The Modbus is the other file that you need to make sure that everything is as per your requirement. So as you can see, there's the slave ID. So the slave ID, you put in whatever is suits for your system, the baud rate as well, um, the parity, the data bits, stop bit. So these are the things which you need to update as per your communication requirements. And the options for different kinds of parity, data bits and stop bit are these. As you can see, these are what the oxygen analyzer can handle, and this is the default, where 8 data bits, 2 stop bits and no parity. One more thing that you need to take into account is that the data that is received by the master, which can be a PLC or a computer, is that the data will all be received as 16-bit integers. Now, the oxygen percentage ideally should have 2 significant digits after the decimal point. So it will come as a multiple of 100. So when you receive the data, you need to divide the received values by these divisors. So for example, flue gas temperature should be divided by 10, oxygen percentage value, whatever you receive at the PLC, should be divided by 100, and so on. And if the oxygen analyzer has any issues, these issues will show up on the LCD, and these issues will also reflect in this entry and this entry. So number 8 is for the thermocouple status, and number 7 is for the oxygen sensor status. So for example, if it is okay, then this oxygen sensor status will show up as 8. If thermocouple is okay, it will show up as 4. If there is any other error, this error code that is given here will be reflected in whatever data is received in number 7 and number 8. So here we will be demonstrating the communication between the Modbus master and the Modbus slave. Modbus slave is the oxygen analyzer, and Modbus master, we are using the simply Modbus master 8.1.2 software. It will be Modbus RTU, and the COM port in our case is 3. The COM port in your case can be as you can check in the device manager. The baud rate, data bit, stop bit and parity should match with whatever you have provided in the SD card file that we demonstrated previously. So there will be 9 registers which the oxygen analyzer will be sending to the Modbus master, which the Modbus master will read. So in this case, the first register begins at 40,001, so we provide an offset of 40,001 as well. And you see, we can send continuously the data at 10-second intervals or 30-second, or as you set it. For this demonstration, we'll just send it once and you will see how it works. So we press the send button and the response happens in 0.4 seconds. And here you see the results of whatever the oxygen analyzer has sent to the registers. Now we will see how to calibrate the oxygen sensor in this oxygen analyzer. So it's very simple. We just need to take it to an open area where you can expect a little bit of a pure air, maybe less pollution, etc., if possible. Otherwise, just take it to an area where there's a good supply of ambient air. And all we need to do is just press the button, this green button, like this for 1 second, and let it go. And as you can see, this is collecting data from the oxygen sensor, thereby calibrating it. It will take about a minute. So the countdown, as you can see, you can see now the oxygen sensor is calibrated, and it will write that data into the SD card, which is available inside the oxygen analyzer. And now, as you can see, the oxygen concentration is going to be close to 20.95. So it's going to be around 21% or so. So here you have it, the oxygen sensor calibrated. Thanks.